Hello everyone, in this video tutorial, we will see how we can implement object detection, tracking, and speed estimation using YOLOv8. So let's get started.
This is the YOLOv8 object tracking with DeepSort Github Repo. I will add this link into the description so you can check it out from there. So here are the details. Google Colab file is also provided, which is a very simple thing. You just need to run cell. But in Windows, we will do the step-by-step implementation. So here are the steps to run the code. First, we need to clone the repository. So I will open PyCharm. So here I have created a folder for this project by the name DeepSort tutorial. Okay, so you can also create a folder for this project as per your requirements, like which drive you suits you. You can just create a folder over there. Okay, so next I will go to File, click on New Project, and then click over here. And I have created a folder by the name DeepSort tutorial. Select it down. Okay, and just click on Create and this window. It might take few seconds more. Okay, so now I will open this terminal. Okay, guys. Just close. Okay, so this is not an issue which is appearing over here. So I will go to the GitHub repo over here and just copy this by clicking over here and just place this over here and press enter. So now our repository is being cloned over here. So it might take a bit few seconds. So let's wait until this completely get cloned. So now our repository is completely cloned and we can see the folder over here by the name YOLOv8 DeepSort object tracking. Okay, so let's move towards the required folder. So I will just copy this over here from here and just paste it over here and just click on enter. Okay, so now our current directory is being set as this folder. Okay, CD stands for current directory. In the next step, I need to install all the required libraries which are necessary to run this project. So if we skip this step, when you run the training or prediction script, you might face this error that the following library is not installed, like Seaborn or Hydra or any other libraries is not installed. So if we run this step, it will install all the necessary libraries that are required to run this project. So just paste it over here. It might take few more seconds to execute. So let's wait and see. You can see that majority of the libraries are already satisfied because I have run this script already multiple times. Okay. So if you're running this script for the first time, then it will take time to install all these libraries. Okay. Now I will now in this video tutorial, like now I am implementing detection, object detection. So what I will do is I will go to Ultralytics, YOLO, V8 and detect. Okay. So I will go to this folder where I have the training, prediction and validation files. So if I am performing segmentation, then I will go to the segmentation folder, but here I am only performing detection. So I will go to the detect folder. Okay, so here we have the uh, script line, code line. So how we can set our current directory as detect folder. So we just copy it from here and just paste it from here. Okay. Now we need to download the DeepSort files from the Google Drive. So just open this link over here, just copy it and open this link over here and see. Okay, so here is the deep sort folder. You need to download this. Okay, so by clicking, just right clicking over here, and so you can just click on download over here, or by just right clicking over here, you can follow this approach by right clicking over here, just click on download. It will download the zip file, and you just need to unzip it and place into this folder where we have the files. Let me show you how we can do this. So I have downloaded and unzipped the folder. So now I have created this folder for this project. I will go to here, YOLOv8, and then I will go to Ultralytics, YOLOv8, detect, and now I will place this deep sort folder over here. So after downloading the zip file from the Google Drive, you just need to unzip it and place this folder over here. So this is the main folder which I have created for this project, deep sort tutorial. Then I go to YOLOv8, deep sort tracking, then Ultralytics, then YOLO, then V8, and then detect, and then just paste this folder over here by the name deep sort pytorch. So, okay, so we have completed this step. Now, basically download a sample video from the Google Drive. So just copy it from here and download a sample video from the Google Drive. So we can test our YOLOv8 model. Okay, so the sample video is downloaded. So now let's see how we can implement object tracking with YOLOv8 and what results do we get. Okay, so I have just copied this script line over here and just paste it over here then. So it might take a few seconds to run. So let's wait and see what results do we get. So it's still processing. It has validated the checkpoints for the deep sort. Now it's downloading the YOLOv8 files from here, YOLOv8 model from here. So it might take few seconds. So let's see what results do we get. And I'm also waiting that it could start running and then. So okay, so basically I don't have a GPU, I have a CPU. So it will take time to run. So it is currently out of 508 epochs, it's currently 4 epoch it has run. So in the meanwhile, till it completely runs and then we can see the output, let's see, or let me explain you the predict.py in which we have the deep sort script. So let's see what we have in our code. I will click on here plus and see what libraries we have imported. So we have imported Hydra, import torch, import time to basically calculate the frame per second FPS. We have imported CV2 library to implement object detection and tracking. Then we have from NumPy import random, basically to assign a different color to each of the detected object. For this, we have imported random library from NumPy. So next we have from collections import DQ. So let me explain you the concept of DQ. So DQ stands for double-ended queue. So DQ is preferred over a list in Python where we need quick append or pop operations. We will be using DQ over here to store the unique IDs of each object. When the object enters a frame, it will assign a unique ID and store it into DQ list. Okay, and when the object leaves the frame, it will remove that object from the DQ list. Okay, so if you want to learn more about this, you can just go over here, Geeks for Greeks, DQ in Python. So DQ is a double-ended queue in Python implemented using the module collections like we import from collections import DQ. DQ is preferred over list in the case where we need quicker append or pop operation from both the ends of the container. Like we need to, from the right here, we append a unique ID when the objects enter in the frame, and from here we remove that unique ID when the object leaves the frame. Okay. So you can see that we can do append dot append will is used to insert the value in the argument to the right end of the DQ, and dot append left, this function is used to insert the value to the left end of the DQ. Okay, so here we are initializing our deep sort tracker. Okay, so next we have define xy to xywh. So in this function we are basically finding our center coordinates of the bounding box. So let me explain you what is this. Just go over here, paint. So for example, this is our bounding box, and here we have some just here we have some object over here, and this is the bounding box. Okay, so what we are doing over here is just no. Okay, so we are finding the center coordinates over here, like what is the x c y c over here, and we are finding the width and height of the bounding box. So first we need to find the center coordinates of the bounding box, and next we will find the width and height of the bounding box. So this function will return us the center coordinates xc, yc, and width and height of the bounding box. Okay, so we are not using this function into this project, so you can remove this over here. Next, we have defined compute colorful labels. So we have here defined if there is a label, if there is a person in the frame, it will assign this color to the person. And if there is a car in the frame, it will assign this. Or if there is a motorbike in the frame, it will assign this specific color. If there is a bus in a frame, it will assign this specific color. Or if we have any other object than this, like for example, we have a truck, so it will basically randomly pick a color and assign to this object. Okay, so here we have defined a draw dash border function. So let me tell you what draw dash border function do is to better explain this. Let me see. Okay, just give me a minute. So you can see a figure over here. This is the sample image taken from the output. So this draw dash border function, what we do is get from this is basically this draw dash border function, this create this UI. Like this whole UI is created by this draw dash border function, this rounded rectangle UI. Like you can see that in draw dash border function create this rounded rectangle UI like this. Here you can see this as well, in which we have the object. Here we are just have written just a unique ID 8 to assign to that object, and here it's directing incorrectly as truck, although it's a car. So using draw dash boxes function, we create a rounded rectangle. In the rounded rectangle, we write the object name and the unique ID. Okay. So in define UI box function, so what UI dash box function is do is it creates a rectangle like you can see over here. It creates a rectangle around a deducted object like you can see here. So to create the rectangle, we use cv2.rectangle to create a rectangle around the detected object. Okay. Plus it put using cv2.put text, it put, it put the text in this UI which we have created using draw dash border function. So we using draw dash border function, we created a rounded rectangle, and in using UI dash box function, we put the text in it, which is unique ID and the detected object name. Okay, so using UI dash box function, we basically create a rectangle around the detected project and put the unique ID and the object name into the UI, which we created using draw dash border. Next, we have the draw dash boxes function. Okay, in the draw dash boxes function, we basically do is we assign each object a unique ID. Over here, you can see that, and plus we basically find the object name. What basically we get find the object name over here, and then we basically put this object name and unique ID into the object. Okay. Plus in the draw dash boxes function, we create a line, trails line. So you can see over here. Okay. So this trails line you can see over here. These are the trails line. Okay. You can see this as well from here as well. Okay. From here as well. So these trails line are created using cv2.line, and through using this we basically create this trail line. So let me also explain you the concept of data DQ over here. Okay. So here we have define DQ, maximum length is equal to 64. So we have said that the list we create using DQ, okay, it has a maximum length of 64. Okay. So what we do is we append the bottom. Okay. So basically this is the center bottom center of the object. You can say that, like the bottom center of the object. So basically in data DQ, we have basically initialize DQ list into a variable data DQ. So in data DQ, basically variable, we append the bottom coordinates of each of the detected object. Like you can say that here we are just appending the bottom coordinates of each of the detected object. So here we are basically finding the code to find the center of bottom edge. So after finding a center of the bottom edge, we are just appending or saving those bottom coordinates into the data DQ list which we have created. Okay. So for example, when the object leaves the frame, it will remove those points from the data DQ. So you can see over here data DQ dot pop key. So when the object leaves that frame, it will remove their coordinates or points from the data DQ list. Okay. Until the object is in the frame, it will be there in the list. As the object leaves the frame, these points will be removed. Okay. So here we are creating a class detection predictor, okay, to implement the object detection over here. So okay, so just here we have initialized our deep sort algorithm. Okay, so here we have initialized deep sort algorithm, and from the deep sort algorithm we are getting bounding boxes coordinates of each of the object, plus we have assigned a unique ID to each of the object using identities, and using object ID we are getting the object name. For example, whether it is a car or it is a whether it is a car, whether it is a truck, or what object. So using object ID, we get the object name for each of the object. And then we are calling a draw dash boxes function, which we have initialized above, and we are just passing those values over there. And here we are just running the predictions. Okay. So our script has run in the meanwhile. Let's see what output do we get. Okay. So just let's open this. So you can see that we are able to track the object as well, and we have assigned a unique ID to each of the object, and we are getting the trails as well. Now, if we want to implement the vehicle counting, so if you want to implement vehicle counting, so just go over there. Okay, so it is saying that just copy this link over here. Okay, just go over there and just download this file over from here. Download anyway. Show in folder. Okay, then what I will do is I will just go over here, Ultralytics, YOLO V8, detect. Okay, so I will just change the name of my previous file. Just change it. Then just paste the new file from here and just now run the script. So it will implement the vehicle counting as well. So let's just run it and let me show you the code we have. Okay, so here we have written the code for the vehicle counting in this cell. So we have just defined a direction north and south over here. So basically, let me show you the direction function. So this is the get direction function we have. Okay, so we have defining the direction as north, south, east, west. So using this direction, we will count the objects entering or leaving. Okay, so if we can say that if south in direction, then we will also do the count. If north in direction, then we will also do the count as well. You can see over here. Okay, so but the difference is where we come is it's let me show you the difference. So Okay, so when we say that in the object counter 1, let me show you where we have the object counter 1. So, okay, if that, for example, if the direction is towards the north, then it means that we have the object number of objects entering. If the direction is south, then we can say that the objects are leaving. Okay, so how we are defining a direction? For example, if our direction is this, okay, this is our direction, then it means that the objects are leaving. And if the object is moving this in the north direction, this is north direction, then we can say that the objects are entering. So, and this is the south direction we have. So we are saying that if the objects are going here, then it means the objects are leaving. And if the objects are passing over here, the north direction, it means the objects are entering. Okay. So if south in direction, it means the objects are leaving. And if north in direction, it means the objects are entering. Okay. So we have defined over here number of vehicles entering. And here we are defining the width and the space where we need to put that text in here. Okay, so here we are just setting the number of vehicles leaving, and we are just setting the space where we need to put that text. Okay, so all the other code will remain the same and nothing we will change. Okay, so just waiting for the script to run, and then I will show you the output as well. So as the script is taking quite some time to run, so I have already run the script, and let me show you the output. What do we get from here? Okay, so you can see that as the vehicle enters, the count increases. You can see over here as well. So the bus or car crosses this line, the count automatically increases, like you can see over here. So our script is working quite fine. Okay, so next thing we can implement is speed estimation. Okay, so let's implement the concept of speed estimation in this script. So here I have defined speed line queue as an empty dictionary it is currently, and here I've written the estimate speed function over here, as you can see over here, and plus I have made few change in the code as well. Like here I am calling this function estimate speed over here, and then I am appending all the speed values into this dictionary which I have created over here, and just then calculating the speed over here. So just let's run this script now and see what output do we get. Are we able to get speed in the output, or if there is an issue, then we'll definitely fix it. So just terminate this script currently by pressing Ctrl C, and just run this script now by clicking on enter, and show is equal to true. So let's see what output do we get now. And if there is any issue, we will definitely fix it. So it might take few seconds to run. Okay. So currently I'm not getting the script speed, but it's running. It will take some time. So let's see when it, okay, name math is not defined. So I will just go to the top and just write over here, import math. Okay, guys. And now just run this script cell. So it might take some time. So when it completes, I will back and show you the output results as well. In the meanwhile, the script is learning. Let me explain you the concept of estimate speed, how we are calculating the speed over here. Let me explain you this. So here have used Euclidean distance formula. What is Euclidean? So here we have used Euclidean distance formula over here. So let me show you the formula. So this is the Euclidean distance formula, x2 minus x1 square plus y2 minus y1 power square. Okay, so if we see over here, here we are taking square root and using mat.pow. Pow means pow means power. Okay, so here we have said this is our x2 and this is our x1, and we are taking a square of 2, and this is our y2 and this is our y1 minus y1, and we are taking a square of 2 as well. So you, by writing 3, you can take a square of 3 or 4, you can define as per your requirements. Here we have defined pixel per meter as 8. We can make this value dynamic as well, closer to the camera 20 and away from the camera 1. And So as we know the formula of this here now we are calculating distance in meter, which is distance in pixel divided by ppm pixel per meter. And here we have the time constant. This is the constant value which is 0.15 multiplied 3.6. And here we are calculating speed. So as we know that distance is equal to speed over time. Distance is equal to speed over time. So speed is equal to distance multiplied time. So get the speed in the end. Okay. So in this way, we are calculating the speed. So here when we get the estimate speed, we just append this speed into the list which we have created above. Okay. And plus anything further which I need to explain. Let's also discuss how the vehicle count increases. So this is the output image which I have taken from the recent video, output video which we have played, like the how the vehicle count is increasing. So basically, let me tell you one thing. When the car or any vehicle crosses this line which we have created, the vehicle count increases. Like if this car crosses this line, then the vehicle count will be 7. Okay. If some bus crosses this line, then the bus count will increase. And if this basically a vehicle crosses the line, then the number of vehicles count will be increasing. Okay. So this is few things which we need to remember. Plus, so like where I have implemented this, let me show you as well. So you can see that here I've created the intersect. So when the vehicle crosses the line, so this is the line which we have defined, which we have created. So CV2 dot line is this line which we have created in green color. So you can see. So when the car crosses this line, it blinks and turn into white the line. So okay, so when so in the is the direction is in the south, then the number of vehicles leaving increases, and if the direction is in the north, then the number of vehicles entering increases. Okay, so in this way we have implemented. So and we don't estimate the speed of the vehicles when the car basically passes this line. So if the vehicle is over here or here, we are estimating the speed. Okay, so let's see if we have some time. It's still taking some time to run. So let's see what the results do we get. Finally, guys, the script has run successfully. Now see what output do we get. So we will go to the detect, runs, detect, train 4, where our output is, and test 3, and see that. Okay, so it's vehicle counting, speed estimation. Oh, okay, everything is very well done. So you can see that we are able to do speed estimation with the vehicle counting and everything else. So if you want to implement this project, just follow the steps in the tutorial and you can implement this project on your side as well. See you all in the next tutorial. Till then, bye-bye.